Okay, to start our look here at preparing standard solutions, here's a worksheet showing several pieces of glassware or different equipment that you would use in the chemical laboratory. Uh, Many of them we've encountered before. Some of them are not as important for preparing solutions. Down here is a distillation apparatus, which would be used to purify a solution when there's different components to the mixture. If you just take a moment right now and pause the video and just try to identify as many as you can from your experience, I'll reveal the names of these now. And here you'll find the equipment name. So we have meniscus finder in the top left to identify where the meniscus is. It's sort of just like a small magnifying glass, pipette bulb, test tube, a U-shaped tube, mortar and pestle for grinding up solids. We have graduated cylinder, beaker, volumetric flask is a very important piece of equipment for precise solution volume. We have a graduated pipette, and then we have a volumetric pipette. We have a burette, which is often used for dispensing solutions of precise volume. We have a weighing boat or a mass boat here for using on a scale. Of course, thermometer for measuring solution temperatures. We have Erlenmeyer or a conical flask using droppers, dropper bottles. We have watch glasses for maybe dispensing small amounts of the solute before we're massing it. We have funnels for pouring into Erlenmeyer flasks, or in this case, maybe the volumetric flask. Evaporating dish for evaporating off solutions to recover the solute. Wash bottle is a convenient piece of equipment to have to top up our volume into the neck of the volumetric flask very slowly. We have funnel rack for filtration. We have the filtration apparatus shown at the bottom. And then we also have the Hoffman apparatus, which you may have seen, where we can take a solution and separate it into its component gases. That's the electrolysis of water. So all this equipment we find useful to prepare accurate and in many cases precise solutions. I just point out that a volumetric pipette, for example, is more precise than a graduated pipette. How we use it, the accuracy of the experimenter can also come into play here. So what I want to do now is to just show you the basic steps for preparing a standard solution from a solid. So you have in your package a worksheet with some blanks, and you also have the standard solution by dilution. We're just going to look in this case today at preparing a standard solution from a solid. So you can fill in the blanks that you have on your worksheet. The first step is more of a numerical step. You're going to do some calculations to determine the mass that you need to dispense. So that's based on the molar concentration formula and the mass from moles and molar mass. The next step is going to involve using a mass balance as precise as possible. Checking the accuracy of it with standard masses is often a good idea. Don't use these much anymore, the beam balances, but they used to be common before electronic scales were available. Quite often when we place our mass boat on the balance, we of course zero it before we put the solid in. And we may want to mass the weighing boat itself, because when we remove the solute from the weighing boat, if some remains, we would know that if we knew the mass of the empty weighing boat. Dissolving is always done in a beaker. So we start with a beaker that's large enough to contain at least a significant amount of solvent, although in this case a lot of the solvent is going to be added to the volumetric flask. So with the stirring rod, we're dissolving the solute into the solvent that we begin with, and in this case the amount that we use is not particularly important. We're going to pour that by transfer using the stirring rod, and we're going to pour down the length of the stirring rod, and it'll just help us to direct the solution into the volumetric flask. We always use a funnel at this point to make sure that we don't spill any of our solute. At this point, if we lose solute, we're going to be very off on our final concentration. because all of the solute is contained in this beaker. So we're going to be transferring, and then we're going to be rinsing and retransferring. And usually 3 or 4 rinses of the beaker is sufficient to remove all the solute from the beaker, and we want to wash down the sides of it as well using the distilled water from the wash bottle. Once we've transferred as much of that with the rinsings as necessary, we shouldn't have full volume in the volumetric flask, and at this point we would be topping the volumetric flask up with the wash bottle, or potentially a eyedropper, depending on how much control we have over adding the water. At this point, all the solvent has been added. We would add up to the mark. Here's where the meniscus finder might be useful to use, because we want to identify where on the volumetric flask is the meniscus, and does it match the line that corresponds to the final volume. So a volumetric flask doesn't have graduations on the side. It has one line at the top which tells you when you're at the mark. If you go above that, you'll have added too much solvent. If you want to make sure you're right at the mark, you could use a meniscus finder, or at least hold it up to eye level. Adding a stopper at the top is going to be important now, because we at this point should have all of the solute dissolved. That should have been done back in step 4 with the transferring. But we just want to make sure that we are uniformly mixing the solution so that we don't have pockets that are more concentrated than others. The solute, as it's dissolved, may have a different density than water, so we want to make sure that our solution has a uniform density and it's well mixed. So we usually invert, and as we invert, pressure might build up in the airspace, so we want to just gradually release that pressure by opening the stopper, usually away from yourself and away from any other experimenters, just in case the pressure releases a little bit of the solution. If we lose solution at this point during this process, not a big deal. We've made a solution with the concentration that we needed based on this first step here. There was our C value. We've masked out, and we believe we've transferred all of the solute, so the solute should all be contained in this. If we lose a little bit of the solution, yes, we've lost solute, but we've also lost solvent. So the concentration of this should now be constant, even if we lose some or if we dispense some. We want to keep it stoppered to make sure that no evaporation occurs, or that no additional water vapor could condense inside. So those are the steps involved in preparing a standard solution. And really this just brings out the definition of a standard solution, which is a solution of known concentration. And in your textbooks you'll see this in section 6.5, a solution for which the precise concentration is known. So you can record that definition simply as one which has a precisely known concentration. We're preparing it using precise and accurate methods, so that's the procedure involved in preparing a standard solution. These steps right here kind of parallel the steps which are shown in your worksheet. So you can list them now: calculation, mass measurement, dissolving, transferring, bringing to volume, and mixing are the things that you would want to record in this part of the handout. So the activity 1 for now, we can hold off on that. We're going to be preparing standard solutions for exploring the effect of diluting a solution on pH, so we'll have an opportunity to make some standard solutions. Let's at this point just refer you to the student worksheet, which you can use as additional practice on molar concentration. And I think you'll find in all of these questions you'll see mole per liter, or in some cases millimole per liter. Where did I see that? In number 2. So whenever you see millimole per liter, you can divide by 1,000 if you want to bring it back to mole per liter, or you can just use it as is and just know that your answer will be milliliters when you try to solve for a volume. We'll work on these in class, so I think at this point I'll close off this portion of the video. I'll do a second portion that relates to solution dilution. Okay, so just to review, your equipment, you should be familiar with the names of a lot of these pieces of equipment. You should be familiar with the steps so that when we start doing this, you're very clear at least on the steps, and you can use this worksheet alongside you at the lab bench, and you get some good practice making your standard solution. Okay, at this point, I'm not going to assign any questions outside of these worksheets. I think there'll be enough to get you practiced on that, so you can count on after you've finished this note, having some time in class to work on these questions here. Take care.